We are experiencing the consequences of huge environmental damage that we humans are causing to the planet. Think of environmental pollution, land degradation, global warming, climate change, scarcity of potable water, and biodiversity. But we are also realizing that nature is willing to help us. And building with nature is such a concept where nature can be used to cope with climate change risks such as floods, waves, and sea level rise, resulting in sustainable solution. We also know that ports are essential to a country's economy. These are located in or near valuable ecosystems. It is being proposed that we develop ports using building with nature concepts and at the same time create opportunities for nature. At the section Ports and Waterways at the Delft University of Technology in the Netherlands, we carried out a case study to investigate the viability of nature-based solutions. This was carried out as a part of a master's study. The photo of a jetty under construction is from this port project. So the basic question that we are trying to answer is, can we develop ports using building with nature processes and create opportunities for the nature at the same time? My name is Poonam Taneja, and the name of my co-authors and our contact information is listed on this sheet. So what is building with nature? It is an alternative design approach developed by Ecoshape. Now, Ecoshape is a joint initiative of contractors, engineering companies, research, governments, NGOs, and it focuses on using the properties of natural ecosystems to develop solutions in harmony with natural environment. It creates opportunities for nature and lets nature also do part of the work. Here you read smart design for sustainable port development, and indeed using nature is smart. It is smart to widen the solution space by studying and understanding the physical and ecological system. This is more likely to result in solutions aimed at balancing people, planet, and profit. In other words, more sustainable projects, more acceptable to the project proponents and environmental stakeholders. This brings me to the case study. We chose a case study in Indonesia, where the government had announced 24 port projects to be conducted in the future. The port of Kuala Tanjung is situated in North Sumatra on the Strait of Malacca. It is planned to be a large port industrial complex, and when finished, it will be the second largest port in Indonesia. The port is being built by the state-owned port operator Pelendo One, together with Port of Rotterdam Authority from the Netherlands and a Chinese port operator. So when we started the project was already in the initiation phase. There was an existing master plan. The project had 4 phases. The first phase was a multi-purpose terminal, which was already completed in 2018. The second phase is the development of a huge industrial estate. The third is of a container hub, and the fourth one for further urban development. So that though the project location was fixed, we had enough design choices, enough degrees of freedom to examine the viability of a building with nature solution. Some more about the project. The project involves dredging, reclamation to access deeper water, as well as breakwater construction. There is a river which has to be diverted, which means people have to be resettled. These activities, as expected, will have a massive, mostly negative impact on the surroundings. As you can read there, change in river morphology, water quality disturbance, subsidence due to groundwater extraction, disturbance of mudflats and mangroves, and so forth. This brings us to our building with nature design process. It is not very different from a traditional approach in these 4 steps that we understand the system, we identify feasible alternatives, we compare and evaluate alternatives, and we select one and we carry out a detailed design. In that way, it is not very different. They're common to all design processes. What is different is that we use the ecosystem and the environment as the guiding principle. We begin with the sound understanding of how the local ecosystem works, how it affects the port and its functioning, and we try to use system dynamics, the forces of nature such as currents and wind and plant growth. We even try to create room for ecosystem development in the port itself. if possible. So let's apply this 4 steps to our case study. First of all, we have to understand the system. So in order to do so, we studied all the available literature, all the documents as listed on the slide. After this intensive study, we could conclude that the current master plan is driven by functional requirements and economic growth. So what is that? Simply profit. The measures to mitigate the impact of the port development, which we saw earlier, were mostly compensation measures to be implemented at a later stage. So we went on to seek building with nature solutions. We started looking for opportunities, and that is also a part of the step 1 of the building with nature design approach. So in the current master plan, the breakwaters, the hard rubble mound breakwaters, form a major part of the capital expenditure. So we thought maybe these offer an opportunity to improve the current master plan by designing a nature-based alternative. And when we examined the ecological system, it revealed that 17,000 islands of Indonesia are protected from the sea by mangroves, which stabilize the coast, dampen the waves, trap sediments, and then provide ecosystem services. So that seemed a good solution to us. On this slide, on the left side, you see a hard breakwater on a muddy bed. It has many disadvantages, resulting in wave reflection and high erosive stresses. We had the opportunity to improve the master plan by designing a mangrove-based breakwater. Mangrove roots are comparable to permeable structures made of local materials. They let seawater pass through, dampen the waves rather than reflecting them. Waves lose height and energy before they reach the coastline, and the mud can settle behind the structure. Healthy mangrove mud systems are in dynamic equilibrium, whereby waves take the sediments away and the tides bring sediment in. And this is illustrated in the figure on the right. There is a lot of research over mangroves ongoing, but a lot of practical applications are missing. So in that way, our study could contribute to that. This brings us to the next steps in the design approach. 2 alternatives were conceptualized as shown. The alternative on the right consists of terminals constructed offshore and connected to land by bridges. This avoids the diversion of the river in all phases of the project, minimizes the need for land reclamation, limits the impact on the ecology of the estuary. However, creating effective hinterland connections for the port is problematic. The alternative is expensive, and in the absence of breakwaters, the downtime for the bigger ships, the break bulk and container ships, to be served in the final phase is likely to be unacceptable. On the left side is the onshore alternative, so all the terminals are located close to each other, providing the possibility of sharing utilities and cooperation among the terminal operators. And the focus in this design is on the stimulation and use of ecosystem services provided by the mangroves. So our conclusion with the research was that mangrove protection can create a sustainable barrier which grows with sea level rise by trapping sediments. So the next step was to see, are the mangroves applicable at our chosen site? So we studied the conditions for natural establishment of mangroves at the selected location. So what is important is the type of mangrove species, the time of the year, the hydrodynamic conditions. These are the key factors in determining whether mangroves can grow, but also relevant factors are the climate, the inundation time, the bed elevation, the bed slope, minimum width required to enable wave dampening, the wave climate, the soil conditions, etc. So an initial assessment concluded that the conditions at port of Kuala Tanjung meet the habitat requirements for mangroves to grow. Therefore, a breakwater where mangroves are integrated in the design to dampen waves and enhance nature at the same time was proposed. Having done that, we could go over to the technical design of the breakwater. Below you can see the cross-section of the breakwater that we arrived at. We kept the location and the configuration of the mangrove breakwater same as in the original master plan. In this way, there was sufficient data available over the bathymetry for the preliminary design of the mangrove water, and all the technical requirements such as area requirements were met. And it was easier to compare with the traditional design because that was our objective, to compare the traditional and breakwater design in order to make a convincing case for the decision makers to go for the soft alternative rather than the hard alternative. The breakwater itself is designed to grow naturally by accretion behind the permeable dams. To initiate the sedimentation process, the stretch of land was artificially elevated up to 1.6 meter chart datum, and permeable dams were constructed. The dressed material, silty sand, is reused to create the right conditions for mangroves to grow. And at the deepest location of the breakwater, which requires an enormous amount of fill, the original hard breakwater will be used, but concrete blocks are incorporated to support habitat for crabs, shellfish, and fish. So if we compare the traditional and mangrove breakwater purely on basis of cost, what do we learn? Is it at all feasible to build mangrove breakwaters, even though they are technically sound design can be made? The cost of mangrove breakwaters depends on many factors, including planting, placing permeable dams, and the transportation distance. However, excavation of fill constitutes a significant part of the cost. For an initial comparison, only the cost for supply and placing of fill material were estimated by multiplying fill volumes with a uniform unit rate. And this showed that the mangrove breakwater is about 25 more expensive than the traditional one. And it is because it is largely self-sustaining and grows along with the sea level rise, the maintenance costs are likely to be lower in the future. And we should not forget that the mangroves are a productive ecosystem. Any benefits can be commercially exploited. So if we do make a business case for long term, the project should reflect the direct, indirect, and intangible value created over long term. And this requires more research, but the likelihood is that the benefits are quite large. In conclusion, we would like to state that building with nature design philosophy guided us to identify opportunities for sustainable port development for the port of Kuala Tanjung. We examined the viability of the solution, and we find that in shallow ports, the concept of a naturally growing mangrove breakwater finds application. But of course, only if the site condition meet habitat requirements for mangroves. We also created a checklist with the habitat requirements for mangroves so that any potential port can have a look at this and assess if mangrove forests as ecosystems are applicable. And we think that using these methods and showing the benefits to the stakeholders and communicating these to the stakeholders in an inclusive approach, the port can really benefit, and it's likely to get more support from all the stakeholders and the project proponents. Thank you.